All right, so this week we're going to talk about Numpy, and we're going to break it up into two sections. First, we're going to go over some Numpy basics, how to create them, and some basic operations, and then we're going to do a deeper dive into part two. But first, we need to know what Numpy is. Numpy is one of the basic libraries out there for doing scientific computing. It's it's really performant, and it works on multidimensional array objects. It provides all sorts of tools built in to work with these arrays. So you get really good performance because a lot of it's written at the C-level code compared to Python, so it can be a lot faster. So some sample usages of doing this is to store matrix, solve systems of linear equations, find eigenvalues, vectors, you can do things like matrix decomposition, and solve other linear algebra problems. It stores multidimensional measurements of data. So what does that mean? It means that data is often referenced by a coordinate I and j, or x and y, if you want to think about it. And um, and this grid, if you think of it in GIS terms, represents a two-dimensional space that you could sit on top of a Cartesian plane. So a lot of things in real world, you see this, the raster data information that you get. So the DEMs, which are elevation models, they're just basically squares with a number inside. And think of them that they can be broken down into these NumPy arrays. They support multiple dimensions, so not just two-dimensional and one-dimensional arrays. You can have three, four, five, whatever number of arrays. So you can sort of scale these out. And a lot of times when you work with image data, you're actually sort of breaking it down to these NumPy arrays. So let's take a deeper dive. So the objective of this lesson, like I said before, is to show how to create arrays. We're going to show how to reshape arrays, aggregation methods, and some other matrix operations, from linear algebra. So it all starts with an import. So usually when you do NumPy, when you decide you're going to use NumPy for things, you do import NumPy as NP, and because we like to shorten the name. Then the create array, you would use the numpy.array, and this will give us back an array object, and they can either be a named array or you can make it as a non-named array. The most basic way of doing it is that you would pass in a sequence of information. So here with the first example, we're creating a numpy array called A, and it takes just a single list of values of 1, 2, and 3, and we get out, and here's a representation of it. If you want to create a multi-dimensional object, so we have two two-dimensional matrices, one sitting on top of each other. It's the same function, numpy.array, but the list of lists that we have is automatically put into the right sequence of order. So NumPy is very smart and knows how to sort of organize your data for you. So NumPys can be created also with a given value. We provided them from a list. You can also create NumPys with standard values. So you can say, I want to create an array, a 2 by 3 array matrix, and I want all values to be 7. So use numpy.full, and you pass in your dimensions and then the fill value that you want. And you get your array of all sevens. And then we can also do it. There's also some standard ones that a lot of people use. We have uh, mp.ones, and that fills up a matrix. In this case, a 2 by 3 again, with all the value ones as with the data type of float. And you can just do the same thing with 0. You can also create identity matrices using the mp.I, and you just state the number of rows and columns that you want. So in this case, 7. So we're going to get a 7 by 7 matrix with the ones on the diagonals. We can also create NumPy arrays using the range function. Much like the standard range function in Python, they have what's called a range, and it creates the one-dimensional array from 0 to n, where n is your stopping number. And then you can also create even line spaces. So let's say we want to do we have the number 4 to 4.124, whatever I wrote it out, and we want to get an even space numbers between the start and the stop. So you just put in the number of steps that you want for each break, and it puts it in. And notice that we start at 4, and then we go to our final number, and then it even does the even breaks in between for the line space. So when you create NumPy and NumPy creations, a lot of times you're doing this to create. A lot of times people use it to make good test data. So there's some built-in functions with NumPy to create random matrices, and you can make sure that the data that you're creating is uniformly distributed. So you can use the random.random function off of NumPy, give it the dimensions, and you get an array back like that. Or you can say, I want the data to be normalized. So you can say between the values that you want and the size of the matrices that you need, and you get back a normally distributed matrices, in this case between -1 and 1. So far we've seen random numbers that were generated by using floats, but you can also use random numbers to generate random integers as well, and this works the same way. You just say your start and your stop, and it gives you in the dimensions that you want, and then it gives you randomly generated matrices for that matrix. There's a lot of attributes and properties additional just to the information that's stored in there that are helpful when you're working with NumPy arrays. And that's the number, dimension, shape, size, and the actual data type within there. So we've seen right now, we've seen just NumPy arrays with just numerical values in there. But in reality, they can store anything, any type of object. So it could store date times, it could store strings, it could store custom classes inside of there. So you can take advantage of the speed of the NumPy array when you're doing operations and use this as your list-like object. In addition to having storing information in there, NumPys are also indexed. And so the best way to compare it, if we use that arange function, our one-dimensional arrays are going to behave just like lists. So that means we can slice it and do everything like that we had before. We can take steps. We can do that negative indexing that starts from the end of the array and works backwards, or we can start at that zero-based indexing that we get with our our list and go to the nth item and -1 item. But on top of just having a single numerical index, we can also have multi-dimensional arrays, and we would separate of these indexes. So here we're going to get, we can get back our information. Here we have array 1, 2, and we're going to get back our the value 6. So we go down 1, so this is the 0th row, and this is the first one, and then the second one, so 0, 1, 2, and so we get back 6. And then here we have 0, which is here, but then we're putting in -1, so we're starting from the opposite side of our array, and we get back the value 3 as expected. So when you want to do assignment, you can assign values within the existing matrices. If we wanted to, if we have a multidimensional array and we have our rows and our columns, the first, just like we saw before getting the values, we just use the equal sign to assign a value instead of getting the value back. So here we're going to change our first value of array from the original value, which was 1, and change it to 10. So we just put in our 0, 0, and then set equals and the value that we want to set it to. A lot of times when we do examples, we're going to use this data set called iris, and it's going to come up more in the second half, but I want to talk about it a little now. The iris data set contains the following data. It contains 50 samples from 3 different species of irises, so a total of 150 samples. The measurements contain are the sepal length and width, and then the petal length and width. And the format of the data basically has sepal length, sepal width, petal length, and petal width, and they're all numerical data. And this is a lot of times when you're looking around on the internet for examples of how to look things. A lot of people use this data set because it's a very standardized data set to do to show examples in NumPy. Some important terminology that you'll see as we go through is that each row in NumPy is usually referred to as an observation or a sample or an example or a record. And then each column is a feature, so or a predictor or attribute, independent variable. And a lot of people interchange all these terms together when they're talking about their data. So it's just something to be aware of. The column names don't show when you print it out, but we can get this information off of an array by doing feature names on there, and it brings back the names that are in there. So we can see the various information in there, and then they give us some additional information besides the name that it's in centimeters. So some common array operations is that we're going to pass in an iterator this time, and it's going to generate an array. But instead of generating it as integers, even though they are integer values coming out of this range, we're going to say that we're actually going to cast them to floats. So you can say that these numerical values are float in there, so they're represented by the number and then followed by a decimal. We can reshape our data. So we can reshape by passing it in the new dimensions that we want without changing the actual data within it. And we can undo the reshape by calling flatten. So we can take a single one-dimensional array like we had with A, and then reshape it into our 2 by 3 matrix. So we have 2 rows of 3, and then we could say, now I want to flatten it back out and make it that one-dimensional array again. We can concatenate arrays together. So if you have multiple sets of arrays, you can smush them together to create one single array by using np.concatenate. So here we have arrays A, B, and C with various values in it. Then we're going to call np.concatenate and pass in a tuple of arrays, and we get back a single one-dimensional array in this case. But we can also concatenate multi-dimension together, and you can specify how you want the concatenation to occur. So we can specify the axis that we want, how things are smushed together. So here we're going to take our array, reshape it to 2 by 2, and then we're going to concatenate 2 of the arrays together, and we're going to get this new array here. So we sort of double the data based on a different axis. And then here's another way of doing it by setting it to axis 1. So instead of stacking the data, now we're appending it to each individual row on our NumPy array by specifying that axis. And then there's also additional dimensions you can concatenate things on. So here we have this example. We're going to concatenate C and reshape A, and then we're going to add a new column to it by using concatenate as well. And we can do that. And then we can split and stack our data as well. So here's, so first we're going to stack our data. So we have our 2 arrays. We have 0, 1, and then just 1 of 1s, so 2 1s. And we're going to stack it on top of each other. And we can see the result that we have 1 row here and 1 row here. And then we can take this information and we can split it and sort of make it back into its original, or split it into various parts. So we're going to use some looping and look at the various parts that we created when we split our array on the axis that we were interested in this case, the columns. So that is the basic operations of NumPy array. We're going to, and that ends part 1 of the video. The next part will go into doing more of the getting actual data from columns, like aggregations and stuff like that.